This video is about how to balance chemical equations. Before we get into the details on the steps toward balancing a chemical equation, it's important to have a little bit of background information. First of all, chemical reactions. It's important that you understand what one is. In a chemical reaction, you have substances, which are elements or compounds, that interact with each other, and as a result, they're changed into other substances, either compounds or elements. Written as a formula or an equation, it kind of looks like this. In this case, you have two hydrogen molecules and two gas molecules and two oxygen gas molecules. They react with each other to create two water molecules. You'll notice there is one side called the reactants. Those are the substrates that react with each other so that when combined, they can produce other substances. And on the other side of the arrow, or the yield sign, we have the products. These are the substances that are actually produced from the chemical reaction. In other words, the reactants react with each other to create the products. The reactants are on the left-hand side of the equation, and the products are on the right-hand side of the equation. In balancing chemical equations, we need to understand the first law of thermodynamics, or the law of conservation of mass. What that basically says is that in a closed system, matter and energy cannot be created or destroyed. So in other words, you'll find that the number of atoms for each element that are on the reactants side of the equation are equal to the number of atoms for each element on the product side of the equation. Those numbers cannot be out of balance because matter cannot be created or destroyed. So let's start talking about balancing chemical equations. The first step is to actually take inventory of the atoms for each of the elements on the reactant and the product sides of the equation. In this case, we have NH3, which is ammonia. H2SO4 yields NH4 to SO4. Your reactants are NH3 and H2SO4. Your product is something called NH42SO4. We want to actually take inventory of how many atoms there are for each element. So, we do this with this little table. We create this table. First, we're going to identify what elements are on each side. First, you see we have nitrogen, so I'm going to list that as an element. Then we have hydrogen. I'm going to list that as an element. I don't need to do the other hydrogen again because we've already listed it, but now I have sulfur. That's the next element I'm going to list. And then oxygen as my last one. If I look at the product side, I have the same exact elements on that side. Now we're going to take inventory. If you look, I have one nitrogen. It's the only nitrogen on the reactant side. I have 5 hydrogens. There are 3 hydrogens in the NH3 molecule, and there's 2 hydrogens in the H2SO4 molecule, giving me a total of 5 on the reactant side. I only have 1 sulfur, and I have 4 oxygens. So now we have an inventory of what's on the reactant side. Now let's look at the product side. A little more difficult. I have 2 nitrogen atoms. I have 1 times the subscript of 2, giving me 2. Hydrogen is going to be 8. I have 4 hydrogens, but that needs to be multiplied by 2, as you can see. That gives me 8. Sulfur, I have 1. And oxygen, I have 4. Now we have the inventory on the product side. You can now see that not everything balances. If you look at nitrogen, I have 1 on the reactant side, but 2 on the product. That's not possible. On hydrogen, I have 5 on the reactant side and 8 on the product. That's not possible either. Sulfur and oxygen are fine. I have one sulfur on each side, and I have 4 oxygens on each side. They're balanced. So, how do we go about balancing? We play around with the coefficients. Okay? So, I'm going to change the coefficients, which is why we have the boxes here, in order to change the number of atoms. The number of atoms of each element. There's some rules to follow here. First, to start doing the balancing, you can start with any element in which the atoms are not balanced on both sides of the equation. We already identified 2 that are not balanced. You can only change the coefficients to balance the number of atoms. In other words, change the number of molecules. You can't change the subscripts, because if you change the subscripts, you're actually changing what kind of molecule it is. NH3 is something different than NH6, let's say. And when you change the atom count of one atom in a molecule, you need to change the atom count for all the elements in the molecule. So in other words, if I change the number of nitrogen atoms in NH3 by saying we're going to have 2 molecules, it means that I must also increase my number of hydrogen, because the coefficient applies to the entire molecule. You'll see a little bit more as we go along. So let's work here. We had identified that nitrogen was out of balance. There were 2 on the product side, but there was only 1 on the reactant side. So I would like to have 2 on the reactant side so they balance. So I'm going to throw in a coefficient of 2, meaning instead of having 1 molecule of NH3, I'm going to have 2 molecules of NH3. 2 times 1 tells me I now have 2 nitrogens. However, the second I do that, I'm going to mess around with my hydrogens. So, I now have that same coefficient now has given me 2 times 3 hydrogens is 6. And when I add that to the 2 hydrogens that are in H2SO4, I actually have 8 hydrogens. Turns out I have now balanced this equation. I now have 2 Sorry, I had a problem here. I now have 2 nitrogen atoms on my reactant side and 2 on my product side. I now have 8 hydrogens on my reactant side and 8 on my product side. I now have 1 sulfur on my reactant side and I have 1 on my product side. And I have 4 oxygens on my reactant side and I have 4 on the product side. If I wanted to quality control check this, I could do my math straight, my original inventory. I could take the inventory with this particular formula. Okay, so now what we're going to do is we're going to give you the opportunity to do some practice. If I can figure out how to do this. Okay, so we're going to use this formula, FeCl3. So there's a certain amount of that, plus a certain amount of MgO, plus a certain amount of Fe2O3. plus a certain amount of MgCl2. Why don't you take some time, pause this video, take some time, and start by taking inventory of everything on the reactant side and on the product side. When you're done, come back. I'll go over those numbers with you, show you how I did it, and then we'll pause again for you to do the actual balancing. Okay, so here we go. We identify that there's Fe, or iron, as one of the elements. Next, I see that there's Cl, or chlorine, as a second element. A third element would be magnesium, and a fourth one would be oxygen. We've now listed all the elements. Now let's get a count. There is 1 iron on the reactant side. There are 3 chlorine, 1 magnesium, and 1 oxygen. On the product side, I have 2 iron, 3 oxygen. Whoops, sorry, I didn't go to the oxygen yet. I go to chlorine next. I have 2 chlorine. I have 1 magnesium, and I have 3 oxygen. Again, now we can take a look at this, and we can see that iron, chlorine, and oxygen are not balanced. Only magnesium is. Next step I want you to do is to try to balance this. So again, you can pause this video and come back and see how it goes. I will walk you through the rest of it. Okay, here we go. The first thing I'm going to do is try to balance iron. I'm going to put a coefficient of 2 in front of iron, and as a result, I now am going to have 2 times 1 giving me 2 iron. However, in doing that, by the way, now the irons are in balance, but in doing that, I've now messed around with chlorine. I have to apply that same 2 to the entire molecule, and so 2 times 3 gives me 6 chlorine. Chlorine is out of balance now. It was before, but it's still out of balance. So let's move on. Let's try to balance chlorine. Now I'm going to go over to the product side, and if I have 3 molecules of MgCl2, I now suddenly have 3 times 2 chlorine gives me 6 chlorine. I've now balanced my chlorines. At the same time, however, I'm changing the magnesium because the molecule has magnesium and chlorine that I played with. So 3 times 1 tells me I now have 3 magnesium. Magnesium, which was in balance before, now is not, but I have balanced chlorine. All right, so now let's try to balance magnesium. The way I'm going to do that is I'm going to go back to the reactant side. If I have 3 molecules of MgO, I will now have 3 atoms of magnesium. 3 times the 1 magnesium. Now I've balanced magnesium. But again, I have to apply that 3 to all the atoms in that molecule. So now we got to multiply the oxygen by 3 as well. The arrow is actually wrong here. It should be pointing to O. But now I have to balance the oxygen as well. And so 3 times 1 gives me 3. Looks like I've actually ended up balancing this. So, as you look at this, I have 2 iron on the reactant and on the product, 6 chlorine on the reactant and the product side. I have 3 magnesium on the reactant and the product side, and I have 3 oxygen on the reactant and the product side. If you got through this, you pretty much understand how to balance chemical equations.